Okay, so let's zip through this as a long division problem real quick. All right, I gotta make my long division bracket, right? What goes inside? Okay, numerator goes inside. Am I missing any terms? Nope, no, I'm not. So I know I just need to have, those are the right number of terms. There's a way you can check, by the way. This is a good little initial check to do. If I look at the degree of this, if the degree equals 4, how many columns, or how many, we'll just say how many terms. How many terms will this have? Exactly. It's always going to have one more than the degree, isn't it? Right? The degree, so the degree is the highest power. If the highest power is 4, well, we're going to get one term for each of the powers of x plus an extra one for the constant, right? Which is the 0 power of x. So we should have 5 terms, 1, 2, we do. We have 5 terms, so nothing's been skipped. It's a quick way to check. So we got 2x to the 4th plus 3x cubed minus x squared minus x minus 8. What goes out front? X plus 2. Good. There's our denominator. All right, so how do we get the first term of our answer? Oh, yeah, okay. X times what, right? We're asking the question here. X times what is 2x to the 4th? What's the answer? 2x to the 3rd. Good. And we can also get that by just dividing those. Leading term inside divided by leading term outside gives us, what did you say it was? We get 2x cubed. There we go. Good. So 2x cubed. What do I do if I have a number outside? Multiply. Okay, so I'm going to multiply by all that stuff. And if I multiply by all that stuff, what am I going to get? I already messed up my colors. I got to pick a new color here. We're going to go with that color, I guess. So 2x cubed times x is 2x to the 4th. 2x cubed times 2 is 4x cubed, right? So that's positive 4x cubed. Then remember, I'm going to put the whole thing in brackets and put a minus sign outside and subtract in triangles. 2x to the 4th minus 2x to the 4th cancels. 3x cubed minus 4x cubed is what? Negative x cubed. What do I do with all these other guys? Drop them down. If there's no term below, I just drop the top term down. Okay? Go again. Just x times what is negative x cubed? Negative x squared. And again, I can also get that if I want by saying negative x cubed divided by x is negative x squared. So I multiply by what's out front, and I get negative x squared times x is negative x cubed. Those guys always have to be the same, don't they? Every time. Negative x squared times positive 2 is negative 2x squared. I put brackets around it, negative sign out front to remind me I'm subtracting in triangles, and I do that. These guys cancel. Negative x cubed minus negative, so plus 2x cubed is what? X squared. Now, you can just focus on the numbers because I know I'm in the x squared column, right? So I know I'm going to get x squareds. Just focus on the coefficients. Negative 1 plus 2 is positive 1, right? So I know I'm getting positive 1 x squared minus x minus 8. Go again. X times what is x squared? X, positive x, right? So I put a plus x. I distribute. X times x is x squared. X times 2 is 2x. So I put a plus 2x. I subtract in triangles. And X squared minus x squared cancels. This is our x column. -1 minus 2 is -3. So I get a -3x minus 8. And we go, how many more times am I going to go here? One more, right? Because this is an x to the 1 and this is an x to the 1. But next time around, this has got to be the last hurrah here, right, for this problem. Next time around, when I subtract, the x's are going to go away. So I can already predict that this is the last time I have to do this process, right? X times what is -3x? -3, okay? So we get a -3. We distribute. -3 times x is -3x. -3 times +2 is -6. And we put it in brackets and subtract. And what do we get? Those guys cancel. -8 minus negative, so plus 6. -8 plus 6 is -2. And that's my remainder, isn't it? Right? That makes sense? Okay. So now what is our answer? Let me make this just a little bit smaller so we can see everything. What's my answer going to be? Even a little bit smaller than that. Let's go down to there. Ooh, that's pretty small, but what's my answer going to be? What goes up here? Okay, yeah, that's the top part, right? The polynomial part. So my answer looks like -2x cubed minus, positive 2x cubed, whoops, minus x squared plus x minus 3. We'll look at this bigger in a second. Plus, what's my remainder? Okay, good. So we get -2. And on the bottom, we've got our original denominator, right? So that is, let's go back and admire our handiwork here. There it is, right? There's our answer. Okay, give me 1 to 5. Is that making sense? Everybody good with that? It's a long process. Everybody hates polynomial long division. It just takes, it's just long. I mean, no matter what level of math you're in, nobody loves doing that. Yep. No, 2 at the most of that. Yeah. Okay, so there's our answer. And I'm going to take a picture of that because we're going to use this to come up with a much quicker strategy. That one, we did that one first period on the board today, and it took almost 15 minutes for everybody to do it, right? That's time consuming. The trick I'm going to show you that works for problems like this, let's get phones away, please. The trick I'm going to show you will take you about 30 seconds once you practice it a few times. Seriously, it's that quick. So x divided by the top ones that have x? No, you can't. Can't do that. No. Can't do that. It'd be nice. Okay, so what I want to show you here, everybody take a look at this. I want to show you guys a trick, not really a trick, it's just a technique called synthetic division. Now you have to be very careful with this though, because you can only use synthetic division in certain situations, and they're kind of limited. You can only use synthetic division when the denominator is linear and it looks like this. It looks like x plus a number or x minus a number. If it doesn't look like that, we're stuck using long division. Okay, so you guys tell me real quick, give me thumbs up or down on some examples. That one right there, could I use synthetic division? Thumbs up or down? Thumbs up, right? I can't. Look at the denominator. X plus a number, x plus 2. I'm good. That one works. How about that guy? How come? Thumbs down? X squared. Can't have an x squared in the bottom. That's thumbs down. How about that one? Thumbs up. Yeah, absolutely. It's x minus a number. How about that one? Thumbs down. I've got an x squared. I've got x squared and I've got another x term, right? That's no good. And then finally, how about that one? Okay, that one is technically it's a thumbs down for us. It's a thumbs down for us because the bottom doesn't look like x. I've got a coefficient of 2 in front of the x, and it has to be a coefficient of 1. It has to be a plain old x plus a number or x minus a number. And this one isn't like that. Okay, in reality, the answer is you could. It's just tricky. I'm not going to take the time to show you guys that. I feel like it's not worth it to go through all that hassle. It's better just to use long division on those cases. If you want to learn it, I will show it to you. It's doable. It just takes a little bit of a few extra steps. Okay. Honestly, I feel like in most cases people would say, oh, I'd rather just do long division for those. Okay. All right. So now let's go back and look at the same problem we just did, and let's use this new process called synthetic division. Okay. Uh, Here's how you do it. So pay close attention to this. You might want to even write down a few notes on this. I will post this. Okay, does everybody know how to get to my instructional notes? Does anybody not know how? Because you're going to need to get to them on this to see this stuff. Okay, if you don't, come up and see me. It takes me 10 seconds to show you. There's two easy places to find them, Plan Book or in Google Classroom. If you go to instructional notes, it's easy to get to them there. Here's how you do it. You start off, you make a bracket. You make a little L-shaped bracket here that looks like that. It's how big do you make it? Well, you got to be able to write just 2 rows of number, one right above the other. That's it. So it's not very tall, and you have to make it long enough so you can do this. All of the coefficients. I don't want to do that. I want to be able to put my answer there. All of the coefficients of the answer are what you're going to put in your top row. You write no variables using synthetic division. All you write down are numbers. So we're writing down coefficients. We have the same rule, however, that we had before. You have to have a column for every power of x. So how many numbers do I need to have in the top row here? Got to have 5 because the degree is 4, right? And I can see I'm not skipping any powers of x, but if I did, I would have to put a 0 for that power of x, for that coefficient, okay? So what am I going to write here? What numbers am I writing down in my top row? 2, 3, -1, -1, and -8. Good, okay? And after I do that, I'm immediately right below the last number, below the bracket, I'm going to make a remainder box, okay? Because that is where my remainder is guaranteed to go, okay? Now what? Okay, the next thing you do is we're going to put a number out front. The number out front is going to be the 0 of the denominator. So what is the 0 of the denominator? What's the value of x that makes it 0? -2, right? When is x plus 2 equal to 0? When x is -2. Let's get rid of all earbuds, please. I don't want to see any earbuds out there. Earbuds are gone. So the number out front is -2. Give me 1 to 5 on that. Everybody understand why? Okay, it's not what the mistake people are going to make is what number are they going to write out there if they do it wrong? Uh, well, I mean, maybe, but I'd say more than likely, when I look at these on a test and people miss this, they put a +2 there instead of a -2 there, right? It's always going to be the 0 of that denominator, right? The denominator always has to be x plus a number or x minus a number, right? So this is pretty easy. It's always going to be the opposite of that number, isn't it? Every time, right? That's the opposite of whatever that number is going to be the value that x would need to be to make the bottom equal 0, right? You'll get in the hang of it pretty quickly. Okay, so now we're all set up and ready to go. Here's how you do the process. As soon as you've got all the numbers written in the top row, you've got the number out front, you take the first coefficient and you drop it all the way down below the bracket and write it down there. Okay, this is where our answer is going to end up showing up. Okay, so that's actually the first part of our answer, that too. Here's the rule. Whenever a number appears below the bracket, you immediately multiply that number times what's out front. Well, 2 times -2 is -4. You're going to put that number, whoops, I got the wrong color there. You're going to put that number in the next column, and you do the opposite of the operation you do for long division. With long division, what do you do vertically? Add or subtract? You subtract, don't you, right? So what are we going to do here? We're going to add, right? Synthetic division, you do the opposite. It's different than long division. You do the opposite. We add those up. 3 plus -4 is -1. Okay, so what's coming next here, Andre? I got a new number below. What do you think I do? What's our rule? When a number appears below, what do we do? Yeah, good. We multiply by the outside number. So -1 times -2 is 2. Where does it go? Below the -1. There you go. It goes right there. So we get a +2. And everybody add or subtract? Add. -1 plus 2, everybody? 1. Okay. Treasure, I got a new number below. What do I do? Multiply. 1 times -2 is -2. That's going to go there, isn't it? I add. What's -1 plus -2? -3. New number. So what do I do, everybody? Multiply by the outside number. -3 times -2 is +6. I add them. And what do I get? -2. Okay, now that's just a bunch of numbers. See if you guys can make the connection here. How do those tell me the answer? I copied down the answer from previous, right? Let's see. Let's see if we can make that connection. Okay. You don't believe me. Okay, well, we got a skeptic. I understand. I understand. Been known to tell a fib in my life, so you're suspicious about this. Do you see those numbers anywhere? 2, -1, 1, -3. Where do those show up? Okay, but where in the answer? How do those give us the answer? What are those? They're the coefficients, aren't they? Look at that, right? So look what we got here. We've got these. This first one is going to be the coefficient of the leading term, right? Second one is the coefficient of the next term. This is the coefficient of the third term. Coefficient of the next term, which happens to be the constant, right? The -2, well, that's pretty obvious. The -2 is the remainder, and we already know what goes on the bottom. It's the denominator. Yes, sir. Okay, here's how you do the x's. I was about to show you. Good question. You're paying attention. So the way we do the x's is this. You know that these are going to be in the order of the coefficients, right? And this is the remainder. So that one, if it's the last coefficient, that's the constant, right? Guaranteed. We're just going to start at the right. You know, when I say to the right, I mean we're going to start immediately next to the remainder box on the right edge of our numbers and work our way this way. And what I always do is this. I just put little x's below, kind of like bottom right, like almost like subscripts, just so I can keep track. That's the constant. So this must be the coefficient of, well, so I'm thinking powers of x. The lowest is the constant. What's the next biggest term? Would it be x to the 1? There you go. So that's an x. That's going to be, and if I kept going, this would be x to the 4th. That would be x to the 5th. But we ran out of numbers, so we stop. Yes, sir. Okay, good. And then make sure we get the signs in there too. So we got -3. Well, that's a +1. So that means I got to put a plus there. That's a negative. We got to take, does that make sense? And that's it. That's our answer, right? So we can see those are the coefficients. So all I would have to do then is just write this down as, okay, I know I'm getting 2x cubed minus x squared plus x minus 3 plus -2 over my original denominator. And we got it. How about that? Way easier, right? Way easier. Okay. Let's do, I'll tell you what, you guys, you can decide. Would you rather go through this one as a group, or would you want to try it on the board? Okay, try it on the board. Try it on the board, and then we'll go through it together when you're done. Real quick, let's zip through this. It looks like people are doing well with this. Everybody's either got it or is super close. So we're going to make our synthetic bracket, right? What are the coefficients going to be in order? 1. Nope. 1, 0. How come? Because I'm missing an x cubed term, right? Okay, now what? 2. -1. What do I put below the -1? The last number. Box, remainder box. Okay, what number goes out front? 2. The 0 of the denominator, so not -2, 2. Okay, we drop the 1 down, right? Remember, that's our first step. Whatever the first number is, just drops below. As soon as the number goes below, what do? Multiply. 1 times 2 is 2. Plus 0 is times 2 is plus 2 is times 2 is plus -2 is times 2 is 20 plus -1 is 19. We got it, right? That's it. It's helpful. I know this seems like a dorky little thing, but it's helpful to make the bracket big enough that you have room to work and you don't, it doesn't get so messy that you lose track of stuff. Just waste a little paper on this, right? So that's constant, coefficient of x squared, and it's positive, coefficient of x cubed. So our final answer is x cubed plus 2x squared plus 6x plus 10 plus, what's my remainder? 19. And it remains over x minus 2. Don't forget to put that plus there, right? You're not multiplying 10 by that fraction. You're adding the fraction to the rest of that stuff. Okay? Give me thumbs. How we doing? Okay. Jump into the assignment. See if you these start on problem 8 on the assignment. Why don't you do one of those right away? Just so you on the most recent assignment, the long division problems are 1 through 7, and after that, the rest of the assignment are synthetic division problems. Okay, so do a synthetic division problem just to get a little practice.